Chapter 9 Fractions. Let us revise what we have learned about fractions in Class 3. Fraction of a whole. Fraction means a part or parts of a whole. The given figures show the whole divided into equal parts. The rectangle is divided into two equal parts. The shaded part is one of the two equal parts called 1/2. The unshaded part is also 1/2 of the whole. 1/2 is written as 1/2 and is read as 1/2 or 1/2. The rectangle is divided into four parts. The shaded part is one of the four equal parts called 1/4. 1/4 is written as 1/4. It is read as 1/4 or 1/4. The rectangle is divided into four equal parts. The shaded parts are three of the four equal parts, called 3/4. 3/4 is written as 3/4. It is read as 3/4 or 3/4. The rectangle is divided into three equal parts. The shaded part is one out of three equal parts, called 1/3. 1/3 is written as 1/3 and read as 1/3 or 1/3. The rectangle is divided into three equal parts. The shaded part is two out of three equal parts, called 2/3. 2/3 is written as 2/3 and read as 2/3 or 2/3. Chapter 9 Fractions. Let us revise what we have learned about fractions in Class 3. Fraction of a whole. Fraction means a part or parts of a whole. The given figures show the whole divided into equal parts. The rectangle is divided into two equal parts. The shaded part is one of the two equal parts, called 1/2. The unshaded part is also 1/2 of the whole. 1/2 is written as 1/2 and is read as 1/2 or 1/2. The rectangle is divided into four parts. The shaded part is one of the four equal parts, called 1/4. 1/4 is written as 1/4. It is read as 1/4 or 1/4. The rectangle is divided into four equal parts. The shaded parts are three of the four equal parts, called 3/4. 3/4 is written as 3/4. It is read as 3/4 or 3/4. The rectangle is divided into three equal parts. The shaded part is one out of three equal parts, called 1/3. 1/3 is written as 1/3 and read as 1/3 or 1/3. The rectangle is divided into three equal parts. The shaded part is two out of three equal parts, called 2/3. 2/3 is written as fraction of a collection. Do you remember? A fraction is an accurate measure of something that is smaller than one complete unit. A fraction represents part of a collection. Given below is a collection of 9 candles. 5 out of the 9 candles are lit. We say that 5/9 candles are lit. We denote 5/9 as 5/9. Now, look at the figure shown on the right. Here, 3 out of 8 balloons are shaded. We say that 3/8 of balloons are shaded. We denote 3/8 as 3/8. The numbers such as 1/2, 1/3, 1/4, 2/3, 3/4, 5/9, etc. are known as fractional numbers, and their symbols 1/2, 1/3, 1/4, 2/3, 3/4, and 5/9, etc. are known as fractions. A fraction is written as two numbers separated by a horizontal line. The top number of a fraction is the numerator and the bottom number is the denominator. Example, 5 is the numerator, so is 3. And 9 is the denominator, so is 8. In the fraction 5 by 9, 5 is the numerator or the parts to be considered. And 9 is the denominator, that is the total number of parts. Important facts about fractions. If the numerator and denominator of a fraction are the same, the value of that fraction is 1. Value of each of these fractions is equal to 1. 4 by 4, 7 by 7, 8 by 8 and 18 by 18. If the numerator of a fraction is 0 and the value of that fraction is also 0, for example, value of each of these fractions is equal to 0. 0 by 9, 0 by 17, 0 by 19 and 0 by 25. The fraction is meaningless if its denominator is 0. Fractions on the number lines. Fractions can be represented by points on a number line. Let us mark 1 by 2 on a number line. Draw a number line. Mark points to represent the whole numbers 0 and 1. Divide the unit into halves. Mark the point of division. It divides the segment of unit length into two equal parts, so we can name this point as 1 by 2. In order to represent 1 by 3 and 2 by 3 on the number line, divide the unit segment into three equal parts. The points of division are marked as 1 by 3 and 2 by 3. Each part is equal to 1 by 3. Example 1. Represent 4 by 5 on the number line. Solution. Draw a line. Mark the points P and Q for the whole numbers 0 and 1 respectively. Since the denominator is 5, the total number of equal parts is 5. So, divide the unit segment into 5 equal parts. The numerator 4 shows that 4 parts are to be taken. Each division is equal to 1 by 5. Starting from the point P, the fourth point of division X names the required point. Similarly, try to do example 2 for yourself. Equivalent fractions. Look at the shaded parts of the circles given below. The fraction representing the shaded part is given besides each of them. You will see that the shaded portions of these circles are equal. Since the fractions 1 by 2, 2 by 4, 3 by 6, 4 by 8 and 5 by 10 indicate the same part of the circle, we can say that these fractions name the same number. We can express this as 1 by 2 is equal to 2 by 4 is equal to 3 by 6 is equal to 4 by 8 is equal to 5 by 10, etc. Such fractions which represent the same part of an object, though differing in numerals, are called equivalent fractions. Note that each of the above fractions is equal to 1 by 2. To find a fraction equivalent to a given fraction, we have just seen that 1 by 2 is equal to 2 by 4 is equal to 3 by 6, which is equal to 4 by 8, which is equal to 5 by 10, etc. These fractions can also be written as 1 by 2 is equal to 1 into 2 by 2 into 2, which is equal to 1 into 3 by 2 into 3, which is equal to 1 into 4 by 2 into 4, that is equal to 1 into 5 by 2 into 5, etc. Thus, we can multiply the terms of a fraction by the same non-zero number to write an equivalent fraction. Multiplying the numerator and the denominator of a fraction by the same number does not change the size of the fraction. Thus, 1 by 4 is equal to 1 into 2 by 4 into 2, which is equal to 1 into 3 by 4 into 3. That is equal to 1 into 4 by 4 into 4, etc. Equivalent fractions. Look at the shaded parts of the circles given below. The fraction representing the shaded part is given besides each of them. You will see that the shaded portions of these circles are equal. That is, 1 by 4 is equal to 2 by 8, which is equal to 3 by 12, that is equal to 4 by 16, etc. These are all equivalent fractions obtained by multiplying the terms of 1 by 4 by the same counting number. Example: write the next 4 fractions equivalent to 3 by 5. I hope it is easy for you to do, children. We can also use division to find equivalent fractions. Examples: 1 by 2 is equal to 1 divided by 1 by 2 divided by 1, which is equal to 1 by 2. 2 by 4 is equal to 2 divided by 2 by 4 divided by 2, which is equal to 1 by 2. 3 by 6 is equal to 3 divided by 3 by 6 divided by 3, which is equal to 1 by 2. 4 by 8 is equal to 4 divided by 4 by 8 divided by 4, that is 1 by 2. 5 divided by 10 is equal to 5 divided by 2 by 10 divided by 2, which is equal to 1 by 2, etc. The numerator and the denominator are the terms of a fraction. Finding equivalent fraction with a given numerator or denominator. Example 1. Find an equivalent fraction of 2 by 7 with numerator 12. Solution. Here, we need to find the missing numeral in 2 by 7, which is equal to 12 by question mark. The numerator 2 has been multiplied by 6 to get 12. So, we multiply the denominator also by 6. Therefore, 2 by 7 is equal to 2 multiplied by 6 by 7 multiplied by 6, which is equal to 12 by 42. Thus, 2 by 7 and 12 by 42 are equivalent fractions. To show whether two fractions are equivalent or not, consider two equivalent fractions, 4 by 9 and 24 by 54. Cross multiply as shown. 4 multiplied by 54 is equal to 216, and 9 multiplied by 24 is also 216. We find that the two cross products are equal. Thus, if two fractions are equivalent, then numerator of the first multiplied by denominator of the second is equal to denominator of the first multiplied by numerator of the second. Now, find in this example whether the following fractions are equivalent. Like and unlike fractions. Like fractions. Fractions having the same denominator are called like fractions. For example, 2 by 9, 3 by 9, 4 by 9, 1 by 9, 6 by 9, etc. are like fractions. Unlike fractions. Fractions having different denominators are called unlike fractions. For example, 2 by 5, 1 by 2, 6 by 15, 7 by 8, 9 by 13, 8 by 9, etc. are unlike fractions. Unit fractions. A fraction having 1 as the numerator is called a unit fraction. For example, 1 by 5, 1 by 4, 1 by 9, 1 by 7, 1 by 12, etc. are all unit fractions. Comparing fractions. Just as we can compare two whole numbers, we can compare two fractional numbers also. Case 1. Comparing fractions having the same denominator. Observe the shaded parts of the following circles. On comparing the shaded parts, we observe that 1 by 8 is less than 2 by 8, which is less than 3 by 8, that is less than 5 by 8. Or 5 by 8 is greater than 3 by 8, which is greater than 2 by 8, which is greater than 1 by 8. Similarly, for other set of fractions, say 3 by 7, 2 by 7, 1 by 7, 5 by 7, we have 5 by 7 is greater than 3 by 7, which is greater than 2 by 7, that is greater than 1 by 7. Thus we conclude, out of two fractions with the same denominator, the fraction with greater numerator is greater than the fraction with smaller numerator. In general, if we are given a set of fractions with the same denominator, then we arrange them in ascending or descending order according to the ascending or descending order of their numerators. Example 1. Which fraction is greater, 4 by 7 or 6 by 7? Solution. Given fractions are like fractions having denominator 7. Comparing the numerators, we find that 6 is greater than 4, so 6 by 7 is greater than 4 by 7. Do the rest of the examples yourself, children. Case 2. Comparing fractions having the same numerator. Observe the shaded parts of the strips shown below. On comparing the shaded parts, we observe that 1 by 2 is greater than 1 by 3, which is greater than 1 by 4, that is greater than 1 by 5. Or 1 by 5 is less than 1 by 4, which is less than 1 by 3, that is less than 1 by 2. Similarly, for the other set of fractions, say 2 by 3, 2 by 4 and 2 by 6, we have 2 by 3 is greater than 2 by 4, which is greater than 2 by 6. Thus we conclude, out of the two fractions with the same numerator, the one having the smaller denominator is greater than the other. In general, if we are given a set of fractions with the same numerator, then we arrange them in ascending or descending order according to the descending or ascending order of their denominators. Addition of like fractions. Addition of like fractions. Look at the strip given below. It is divided into 9 equal parts. 4 parts of the strip are shaded on the left and 3 parts are shaded on the right. 4 shaded parts represent 4 by 9 and 3 shaded parts represent 3 by 9. There are 7 shaded parts in all, so they represent 7 by 9. 4 shaded parts plus 3 shaded parts is equal to 7 shaded parts. 4 by 9 plus 3 by 9 is equal to 7 by 9. Thus 4 by 9 plus 3 by 9 is equal to 4 plus 3 by 9, that is 7 by 9. Similarly, shaded parts of the circle given on the right show 1 by 8 plus 2 by 8 plus 2 by 8 is equal to 5 by 8. Thus, for fractions having a common denominator, sum of 2 or more fractions is equal to sum of the numerators divided by common denominator. Example 1. Add 3 by 13 and 5 by 13. Solution: 3 by 13 plus 5 by 13 is equal to 3 plus 5 by 13, that is 8 by 13. Subtraction of like fractions. Look at the circular figure on the right. It is divided into 8 equal parts. 5 parts out of 8 equal parts of the circle are shaded. Shaded parts represent 5 by 8 of the whole. Remove 3 shaded parts from it. Now we are left with 2 shaded parts. Thus, 5 shaded parts minus 3 shaded parts is equal to 2 shaded parts. Note, 5 by 8 minus 3 by 8 is equal to 2 by 8. Similarly, 5 by 8 minus 2 by 8 is equal to 5 minus 2 by 8, which is 3 by 8. Thus, when two fractions have a common denominator, the difference of fractions is equal to smaller numerator by common denominator. Maths lab activity. Objective: to find the sum of like fractions by activity method. Materials required: a white sheet of paper, a ruler, a pencil, an eraser and sketch pens. Suppose we want to add 2 by 9 and 3 by 9. Then we proceed as per these steps. Steps: draw 3 rectangles each of dimensions, say 18 centimeters into 2 centimeters, on the white sheet of paper. Divide each rectangle into 9 equal parts. Each part represents 1 by 9 of the whole rectangle. Shade 2 parts of a rectangle as shown in figure 9.1. These shaded parts represent 2 by 9 of the whole. To represent the fraction 3 by 9, shade 3 parts of another rectangle as shown in figure 9.2. As we want to find 2 by 9 plus 3 by 9, we shade 2 parts and 3 parts of the third rectangle as shown in figure 9.3 given below in different colors. Total number of shaded parts in figure 9.3 are 5, which represent 5 by 9 of the whole. Thus, 2 by 9 plus 3 by 9 is equal to 2 plus 3 by 9, which is 5 by 9.